Welcome to the video lecture series on testing of VLSI circuit. Previous videos we saw about the stuck-cut fault, break fault, bridging fault, stuck open faults, etc. In this video lecture, we can see about the delay faults. As it is mentioned in the previous videos, the manufacturing defects in the VLSI can be represented using various types of fault models. The size of the defect determines whether the defect will affect the particular output of the circuit that is designed or not. Smaller defects, which are likely to cause partial open or short in a circuit, has higher probability of occurrence due to the statistical variations in the manufacturing process. So these defects results in the failure of a circuit to meet the timing specification. So, without altering the logic function of the circuit, the timing alone gets varied. A small defect may delay the transition of signal line from 0 to 1 or 1 to 0 and vice versa happen. This results in the delay fault. So, this results in two types of delay faults as of now, and the first one is gate delay fault and the next one is the path delay fault. So gate delay fault occurs when the individual logic gates takes longer than the specified propagation delay to produce the correct output. Propagation delay is the time taken by the given gate to process the input and produce the output. So when it is more than that of the specified time, then it results in gate delay fault. So the major causes of this gate delay fault are manufacturing process variation, aging effects, and also weak transistors inside the circuit, and increase in resistance or capacitance, because the timing constant mainly depends upon RC values. So increase in resistance and capacitance while going for layout or while doing design itself, if it is not taken care, so this may also cause the gate delay faults. And defective transistors within the gate that are available, that is weak transistor as well as defective transistor, they may cause the gate delay faults. These were the major causes of gate delay fault. Coming to the characteristics of gate delay faults, only one gate is low and it results in the localized defect. Even it is easier to diagnose. Usually, it is detected using transition delay test. There is a test called transition delay test, and using that, you can identify the transition delay test. Gate delay faults have been used to model defects that cause actual propagation delay of a faulty gate. When it exceeds the specified worst case value, we'll be having a worst case scenario analysis. Using that, we can do it. For example, if the worst case propagation delay is x unit. Worst gate propagation delay is x unit. And the actual that is coming is x plus del x unit. Then the gate is said to have the delay of size del x. Can you understand? If it is 5 seconds, is the propagation delay, and if it is taking 6 seconds, 1 second delay is happening. That's all. Very simple. X unit means propagation delay. X plus del x unit is the actual delay, means del x is the delay fault. The main deficiency of the delay fault is that it can be used only to model isolated defects, not distributed defects. For example, several small delay defects may occur. So this is the main deficiency of the gate delay fault. Coming on to path delay fault, it occurs when the total delay along the complete signal path exceeds the allowable timing limit, even though each individual gate meet its own delay specification. It comes for a complete circuit. It path delay we call, and path delay we have to check while designing. In the research papers, you can see that the highest possible delay, longest path, well, it's not highest, it is the longest path delay will be calculated, and based on that, the analysis will be done. You can take few reference research papers and you can see the longest path delay is usually taken for consideration while doing the design itself. The characteristics of path delay faults involves multiple gates. Delay accumulates along the path. It is very critical for high-speed processors and application-specific integrated circuit. It is again more difficult to test because many paths exist in a chip. Path delay fault model can be used to model isolated as well as distributed defects. It can model both isolated as well as distributed defect. In the path delay model, the fault is assumed to have occurred if the propagation delay along a path in the circuit under test exceeds the specified limit. Coming on to the feature comparison of both the gate delay and the path delay fault. Delay location in single gate for gate delay, entire signal path. So causes it slows the gate Sum of delays along the path gets slow. Number of gate is 1. Multiple gates are affected in the path delay fault. Transition delay test is used for gate delay fault detection, whereas path delay test is used for path delay fault detection. Complexity is slower for gate delay, whereas it is higher for path delay. And impact is local timing issue happens for gate delay fault. End-to-end timing failure happens for path delay fault. So considering an example scenario, consider a signal is traveling from a register to ungate, from a register it is traveling to AND gate, then to OR, and then to XOR, then the multiplexer, and again register. If OR gate alone is slower than the specified, then it is gate delay fault. For example, this particular OR gate, instead of 5 nanosecond, instead of 2 nanosecond, if it takes 5 nanosecond, then del X, that is 3 nanoseconds is the gate delay occurring, and it is local and it happens only in a single gate OR gate. So it is easier to find using the transition delay test. Path delay fault, every gate operates within the specification. Each and every blocks that are available, they operates within the specification. But the combined delay from the first register to the second register, when it exceeds the clock period, because the whole unit or digital circuits are controlled by clock. When it exceeds the clock period, then the receiving register, it may store the incorrect data, and the forthcoming unit that is behind this register will fetch the wrong data, so it results in complication. So end-to-end timing failure may occur due to this. Though the path delay test is involved in identifying the fault, it is little bit complex. I hope you got an idea about gate delay fault and path delay fault. Now coming on to the conclusion, is the single gate has excessive propagation delay, then it is gate delay fault. When it is combined delay, it is a path delay. In modern VLSI circuit operating at gigahertz frequencies, path delay faults are often more critical than the gate delay fault, because overall timing closure is important, and there will be a separate team in the industries to take care about the timing closure. So it is very, very important. So stay tuned. Thank you. Thank you for patient listening.